Okay, problem number 3. You have this small sphere suspended on a string, length L, which is irrelevant. The sphere is made to move in a horizontal circle, radius r, at constant speed as shown. The center of the circle is labeled point C, and the string makes an angle theta 0 with the vertical. Two students are discussing the motion of the sphere and make the following statements. Student 1 says, none of the forces exerted on the sphere are in the direction of point C, the center of the circular path, therefore I don't see how there can be a centripetal force exerted on the sphere to make it move in a circle. Student 2 says, I see another problem. The tension force exerted by a string is at an angle from the vertical, therefore its vertical component must be less than the weight of mg of the sphere. That means the net force on the sphere has a downward vertical component, and the sphere should move downward as well as moving around in a circle. So we're supposed to state what's incorrect for each of the students. Starting with student 1. He's saying that none of the forces are exerted in the direction of point C, right? That's not entirely true. While, there isn't a direct relationship between the forces exerted, or a direct relationship between where the center of the circle is and where the forces would point initially. There are components to those forces that are pointing towards the center. So, for example, if we're looking at the diagram here, there's a force of tension that goes up along the string here, right? And because that force is at an angle, it does have a component that points towards the center like this, right? As well as a component that points upwards like this. Okay. Additionally from that, there's also the component of weight pointing downwards like this, right? So those would be the forces we would be concerned with, and so there is a force that does point towards the center. It's just not all of the force. In this case, the tension here, right? The force tension has a component in the x direction towards the center. So we would correct this by, or state that there is a component of the tension that points toward the center of the circle. Okay? And then for student 2, they state that the tension force is at an angle and that the vertical component must be less than the weight mg. That's not true. In fact, if it's moving in this pattern, then that means that that vertical component is equal to mg in order to keep it at that height, right? And so they go on to saying that the net force on the sphere has a downward vertical component. That's also not true. Right, so because Ft is greater than mg, right, the vertical component can equal mg and cause there to be no net force in the vertical direction. All right. For B, derive an equation for the magnitude of the net force exerted on the sphere. Express your answer in terms of m, theta, and physical constants is appropriate. So you know what the net force is, right? So looking back at that kind of forces that we drew, we have the component of tension like this, Ft, and then we have mg pointing downwards like this, right? Then there's the components of tension, the one that points in this direction. This would be Ft in the x direction. This would be Ft in the y direction. So we have to write our equations for the net force, right? We know that there's no net force in the y direction, but that's still helpful information because ft in the y direction minus mg should be equal to 0. So we can say that ft in the y direction is equal to mg, right? And ft in the y direction, because this angle here would be theta, right? We could say that fty is ft cosine theta. So ft cosine theta is equal to mg, or in other words, ft is equal to mg or cosine theta, right? The reason is we don't want to have ft in our expression at the end, right? Because it's not one of the things that we're allowed to have for our final expression. And in the x direction, the only force present is that ftx, right? So just ftx is equal to our net force. And that should be equal to ft sine theta, which should be equal to mg cosine theta times sine theta, right? So all we're doing is replacing this mg here with the expression we found here. And then our final answer is going to be that that expression here. That's our net force. All right. Number 2, describe an aspect or step in the derivation of part B that can correctly be linked to your answer to either part A, well, basically in both those there, right? So we know that ftx, since ftx is equal to ft sine theta, and it is not equal to 0, right? It means that student 1 was incorrect. And then for the second part, right, we can see there that fty is equal to mg, right? So the net force in the y direction is 0. Okay?